Hi guys, Mrs. Brumwell here. We are going to cover just two really short pieces of a couple sections in our book, 4.1 and 4.3. This one should look very familiar to you. Honestly, you guys probably don't even need to get the definitions from me. You can probably just fill these in on your own. But we're going to use these definitions about kinds of triangles. So this whole unit is going to be about triangles. And so we need to know what the different varieties of triangles are that we deal with. And so we deal with acute, equiangular, right triangles, and obtuse triangles. These are ways we classify the triangles by their angles. So if all the angles are less than 90, we call it an acute triangle. And one particular kind of acute triangle, when all the angles are 60 degrees, we call that equiangular because all the angles are equal to each other. Here, a right triangle contains one right angle. An obtuse triangle contains one obtuse angle, and remember, obtuse means greater than 90. Okay, we can also classify triangles by their sides. And so equilateral triangles, marked here, you can see all those sides are congruent. So if all three sides are the same length, we call it equilateral. If two of the sides are the same length, it's called an isosceles triangle. And if we have all three sides are a different length, there's no congruent sides, that is called a scalene triangle. Okay, so we're going to practice classifying some triangles here in some examples. All right, so we are going to use this diagram up here to help us classify. So they want us to look at, here's just a triangle symbol. So they want us to classify triangle FGH. So, FGH, this triangle, by its angle measures. Okay, so if these two angles are 60, this one is also 60 because I'm told that this is a right angle. And so if this is 30, this is 60 to be able to add to 90. So if all angles are 60, this is an equiangular, right? We're classifying by its angles. So this is equiangular. Okay? All right, 2, classify that same triangle by its sides. Now, if it's equiangular, guess what? It is also equilateral. Those two will always go together. Equilateral. All right, now we're classifying EHF. EHF. Okay, so this is something else good to know, you guys. So this angle has to be 120 because these two are a linear pair. And if two of the angles are the same, that also means two of the sides are going to be the same. And so I'm going to actually mark this side and this side as being congruent as well. Okay, so angle measures. So we have two acute angles and one obtuse. If it has one obtuse angle, that automatically makes it an obtuse triangle. And since two of the sides are the same, that is an isosceles. So when we're classifying by its side, this is an isosceles triangle. All right, which side length is the largest in EHG? So now we're looking at the big triangle. Okay, so we kind of know this from Pythagorean theorem, but the longest side is always across from the biggest angle. So the smallest side is across from the smallest angle. So in this triangle, I have a 30, 60, and 90. So 90 is the biggest angle. So across from 90 is this side. So EG is the longest side of this triangle. Which side is the smallest? So if 30 was the smallest angle, across from 30 is this side. So H to G is the smallest side. Okay, now we're asked to classify that big triangle by its angle measures. We already kind of picked out that it had a right angle, so this is a right triangle. And by its side lengths. So we know that this is the same as this, but this one's double that, and this one is obviously shorter than this one. If all the angles are different, all the sides are also different. So when we have a triangle that has all different side lengths, remember that is called a scalene triangle. Okay, this example down below, find the value of x. So notice these tick marks tell me that these are congruent. So this side has no relation to these two, but that's okay. I can solve an equation just with these two pieces. So x plus 2.4 has to equal 2x plus 1.7, and the reason I'm setting those equal again is because I'm told they're congruent with those markings in my picture. So I'm just going to subtract x from both sides. So I've got 2.4 equals x plus 1.7. Subtract 1.7 from both sides. And let's see, we get 3, I think we get 0.7 there for x. And there, I was asked to solve for x. If I was asked to find all the sides, then I would just plug x back into each of those pieces. Okay, so that's 4.1, you guys, just talking about classifying triangles. So this next part we're going to get into is maybe something that's a little new. We've talked about corresponding angles before in our last unit. And remember, corresponding, I'm going to actually add this up top. Corresponding means like matching locations. Okay, so if I look at these triangles, and I'm sorry, these letters are pretty small. This is JZX and AQF. So I'm going to add some markings here, you guys. I'm going to give some kind of congruent markings. Okay, so you can kind of see that these triangles look like they're identical. One's just been like flipped over. And so Z and A are like in matching locations. So we would say that angle A and angle Z, we'll say it like this. Angle A corresponds to angle Z. They're in matching locations with their respective triangles. Like if I flipped one, A would land on top of Z. We can say the same thing with J and F. So angle J corresponds to angle F. And then lastly, X and Q. Angle X corresponds to angle Q. Okay, well, we can do the same thing with sides, you guys. We can have corresponding sides. So again, this means like matching locations. So again, I'm just going to add some markings to help us out. So we're going to do these ones. So again, if we think about flipping this triangle over and landing on this one, this side right here would correspond to this side. Now, it is important that I line up the letters. So if I name this side JZ, I don't want to name it AF. It needs to go in the same order. So we just said that J and F corresponded. So since I listed J first, I need to list F first. So I'm going to say the side J to Z corresponds to F to A. So I want to go in the same order because J and F align, Z and A align. Okay, let's try another one. So if I do Z to X, I want to say that that corresponds to, okay, so Z to X, A to Q. Okay, and then lastly, if I did X to J, that's going to correspond to Q to F. All right, okay, so when we have corresponding pieces in a triangle, total I have 6. I have 3 pairs of angles, 3 pairs of sides. If all 3 pairs of angles are congruent and all 3 pairs of sides are congruent, that's actually how we define congruent triangles. Basically that all their corresponding parts are congruent. So I'm going to say triangles, I'm going to use a triangle symbol. Triangles are congruent if all 3 pairs of corresponding sides and, so it has to be both, and corresponding angles are congruent. That is enough to say that those triangles are congruent. So a congruent statement is just stating that 2 things are congruent, but again, the letters match in the right order. So I'm going to say triangle. I'm going to name this one JZX. JZX is congruent to triangle. So if I did JZX, I would have to do FAQ. And again, there's more than one way, but how I name the first one must match how I name the second one. So if I chose to do triangle xzj or xjz. We'll do that. xjz. I could say that that is congruent to QFA. So again, it matters. The orders must match. Okay, so in our congruent statement, the letter lining up is important. That tells us which parts correspond with each other. Okay, last piece of the video, you guys. We got a couple examples. Given the polygon is just another word for shape or a figure that has sides and angles. So they're telling me that this polygon is congruent to this polygon. I identify all pairs of congruent sides and congruent angles. So do you see how the letters line up? So if L is first and E is first, we would say that angle L then has to be congruent to angle E. Angle M is congruent to angle F. Angle N is congruent to angle G. Angle P is congruent to angle H. So that's all the angles, all the sides. This one can be a little harder without a picture. Since there's 4 angles, there also has to be 4 sides. So I'm just going to draw like a rectangle. Okay, so if this one is, and I want to go like around the shape in the order that they give me, it doesn't matter where I start. But if I put L there, M, N, P, I got to start this one the same way. So E matches with L, M with H, N with G, P with H. Okay, so the sides, L and M go with E and H. So we would say side LM is congruent to EF. Okay, M to N has to be congruent to F to G. N to P is congruent to G to H. And P to L is congruent to HE. So sometimes the picture can help with that, but again, the letters, that's what we're trying to line up. Which parts match together? Okay, 1B gives me 2 triangles. It says write a congruency statement. So again, I'm going to name this first one however I want. ABC does not matter the order. I'm going to actually name it CBA. So I want to name this one, oops, sorry, that's a little rough. I want to name this one in that same order. So I could not do ADF. ADF, not work, okay? Has to be in that same order. So if I did C, then B, then A, I would want to do F, E, D. And that's a congruency statement stating that those 2 triangles are similar, lining up those matching parts. Okay. They are telling me that these 2 triangles are congruent. So remember, our definition of congruent means that if the triangles are congruent, all their matching angles are congruent and all their matching sides. So I have to first think about, they want me to find angle E. They want me to find this angle. So I need to say, which angle does that match up with? Well, you can kind of see this triangle is like flipped upside down. Oh, sorry. Let me find the measure of angle X first. Okay, so this triangle is the same, but it's just been flipped upside down. So when they want me to find X, so here's my expression with X, which side does that match up with? The 10 or the 6? Well, I can see that 6 and this ED and AB are lining. Also, here's AB, DE. So AB and DE match up together. So 2X minus 2 has to equal 6. Add the 2 to the other side, and then divide by 2. So find the value of X. There's part A. Now find measure E. So E is right there. E and B line up, E and B. So measure of angle E must also be 53 degrees. All right, guys, thank you for watching. That's it for our introduction video into our module on triangles.